Welcome to another wonderful session here, which is constructing a connection between the homogeneous system to how the eigenvalues and eigenvectors are came into the picture. So please be careful here. We know that the homogeneous system. Before the homogeneous system, we know that here we know that homogeneous linear system is look like Ax equals to B. If B is not equal to 0, then it is non-homogeneous. If B equal to 0, then it is homogeneous. So if B is replaced by 0, then it will become homogeneous system. Once it is homogeneous, what is the advantage is all solution exists always. Solution exists always. So that is here. Solution exists always. Then what about the solution is? The solution exists always means the possibilities are two. One can be unique solution, unique solution. Another one can be infinitely many, infinitely many. This is a origin for, this is origin for eigenvalues and eigenvectors. Okay, how it is origin we'll discuss soon. So first let us discuss about this homogeneous system. It's a, for a homogeneous system, always rank of augmented matrix is equal to rank of augmented matrix is equal to rank of the coefficient matrix, because its last column is 0 and we are using only elementary row operation. So 0 minus 0 or 0 plus 0, it doesn't make a sense. So that's the reason it is a consistent always. Consistent means solution exists. If the solution exists, that can be either unique or infinitely many. If it is unique means, so this value is equal to number of unknowns in the unknown matrix. That means that unique solutions always 0, 0, 0, 0. So that is known as a trivial solution. That is known as a trivial solution. Since the solution vector is represented with the column vector, but here I wrote a row. That's the reason I maintained a transform symbol, a transposition symbol. So it will become a column vector now. Now here is a bigger question: how we are going to construct a bridge between the homogeneous system to eigenvalues, eigenvectors? Let me explain that. Here Ax equals to 0, we know that, which is equals to lambda into x. What is the a and give a minute. Here Ax is equal to lambda x. Why Ax equal to lambda x? Let me show in a beautiful example here. Let x is equals to, let x equals to 1, 2. If I take a column vector of 2 by 2, for to understanding purpose I have taken only 2 by 2 matrix. A solution vector consists of only 2 elements. That's 2 by 1. Now a I'm defining like this. So let it be 5 and 10. This one I can write here. 5 was taken common, 1, 2. And this one I'm writing 1, 2. So that here I'm generating, actually from in this way we need to go, but I'm moving reverse. What I can write here, it is 7 minus 1, and here 6 minus 2. So see this here, the product is 7 minus 2 will be 5, minus 2 plus 12 will be 10. Since it is a 2 by 2 matrix, it is a 2 by 1 matrix. Together I may get here 2 by 1. This 2 by 1 is rewriting further by taking 5 as common 1 2. So if you observe carefully, this is 1 2, this is 1 2, but this is a matrix, it's a number. Were they equal? No. This type of arrangement is possible only a few cases. This value is known as eigenvalue, and this is known as eigenvector. And the condition is x should not be equal to 0. Now come back to this flow chart as we discussed earlier. So only I may get infinitely many solutions. So in this unique x is always 0. Here x is always 0. Here x 0 and a non-zero. So in this non-zero is possible only in this. That's the reason its extension only eigenvalues. So I may define this eigenvalues quite clearly. Whenever capital X is not equal to 0, in the equation Ax equal to lambda x, I'm not considering now. In the equation Ax is equal to lambda x, whenever capital X is not equal to 0, the values of lambda are known as eigenvalues and the values of x are known as eigenvectors. That's like that I may define. Then here we may get a bigger wonder that can we represent every matrix like that? No. So the matrices which can be represented in this way are known as only eigenvectors, means the vectors, the x values which can be represented like this, they are known as eigenvectors, which cannot be represented as writing them as normal vectors. So before going to depth, let me check a problem for homogeneous in the case of both unique and infinitely many. Now these are the problems and exercise. I may take any one of the example and let me check this. So if I go with that first one, because the people are panic when they're seeing more number of equations with less number of variables, so that's the reason I opted this one first here. So from the first equation 1, the a value would be 1 2 3 2 3 1 4 5 4 1 1 minus 2. This is a, and x is x1 x2 x3, and b is 0 0 0. So since b is equal to 0, I clearly indicate that it clearly indicates that it is a homogeneous system. Then augmented matrix and coefficient matrix would be the same, so that's the reason I am starting with only coefficient matrix. So a is here, by using this, my intention is I need to reduce this one to the upper triangular matrix or echelon form simply. So by using our a11 elements below a11 are 0, so I need to update row 2 primes, row 2 based on row 1, row 3 primes, row 3 based on row 1, row 4 primes, row 4 based on row 1. Now check it out, here is 2, here is 1. So if I multiply row 1 with 2, row 1 with 2, since having the same sign, subtract this. And here row 1 is 1, row 3 is 4. So row 1 is multiplied with 4 and then subtract. Row 4 and row 1 are same, so only simple subtraction. So now here the simplification would be 1 2 3, because I am not updating anything to the row 1. Row 2, row 3, row 4 only updating. So these positions we made 0 wantedly. Now 3 minus 4 will be minus 1. Or if you are confusing, as usual, we know that procedure. multiplying row 2 is as it is 2, 3, 1. To the row 1 I need to multiply with 2. 2, 4, 6 and change the sign. So 0, minus 1, minus 5. So this is. But if you practice like this, it is a mere waste of the time. So this is only for those who want to understand the basic essence. That's only. But do not depend on that blindly. If you depend upon blindly, it will consume your time. Next, row 3 minus 4r1. 5 minus 8 will be minus 3. 4 minus 12. See, 4 3 are 12. 4 minus 12 will be minus 8. Then fourth row 4 minus row 1. 1 minus 2 will be minus 1. Minus 2 minus 3 will be minus 5. So this will be the updation. Now, earlier I was here. Now I need to jump from here to here. It's negative 1. Now I need to update row 2 and row 3 only. Sorry, row 3 and row 4 only. Row 3 primes. Row 3 based on row 2. To understand easily that I encircled this here. Similarly, row 4 primes. Row 4 based on row 2. Yeah, check it out here. Here, minus 3 minus 1. Minus 3 minus 1. So if I multiply this with 3 and then change the sign, means I need to multiply row 2 with 3 and the change the sign means minus, because both having the same signs. Similarly, row 4 minus 1 minus 1, both are the same numbers, only change the sign. Now I make it here. Row 1, row 2 will be as it is 1, 2, 3, 0, negative 1, negative 5. These two we made zeros earlier. Now we made these two zeros. Only I need to find this one. Row 3 minus 3 R2. So minus 8 plus 15. Minus 8 plus 15. So plus 7 here. Minus 5 plus 5 will be 0. Now check it out here. We moved from here to here. Then from here to here I supposed to move. But below this already 0. So no need to go for further step. We can stop it here and we can conclude that. So which is also equivalent matrix, remember that. With respect to the rank, these are the equivalent. Now if I check this, rank of the coefficient matrix is equals to this completely 0 row. So 3. Number of unknowns. Means in x. In x, what are the unknowns? x1, x2, x3. So 3. So whenever they are equal, then from this there exists unique solution. How the unique solution? Let me explain that one also. 1, 2, 3. 0, minus 1, minus 5. 0, 0, 7. 0, 0, 0 times, just substituting back in the system, x1, x2, x3. By back substitution would be easy for me. 0, 0, 0. Now if I check this, 0, 0, 0, so nothing can done. 0 x1 plus this one I am writing here, 0 x1 plus 0 x2 plus 7 x3 equal to 0 implies 7 x3 equal to 0 implies x3 equal to 0. That's what. Similarly, next I am writing here 0 x1 minus x2 minus 5x3 equal to 0. But already I know that x3 is 0. So minus x2 equal to 0 implies x2 equal to 0. Again in this x1 plus 2x2 plus 3x3 equal to 0. Since we know that x2 and x3 are 0, I may get x1 equal to 0. So since all are this, therefore the given system is having unique solution. The given system having unique solution, and the solution is this. Let me check with the infinitely many solutions. Suppose let us have this problem. In this, clearly this is also a homogeneous system. This is also a homogeneous system because here, right, 0 0 0. It doesn't mean that 0 is a homogeneous. See, each and every term, degree 1 1 1 1. So here no variable, 1 1 1 1, no variable, 1 1 1, no variable. So if I check this, the coefficient matrix A is 4 2 1 3. Second, 6 3 4 7 2 1. Z is not there, 0. W is 1. This is the coefficient matrix. And unknown matrix X equals to X, Y, Z and W. And the constant matrix B 0 0 0. Because 3 equations I have. Now let me check whether we may get this or not. As usual, I need to try this one. The elements below must be 0, then I need to move from here to here. Elements below must be 0. That's my work progress. So let me check first. Here, by using row 1, I need to update row 2. Means by using A11, I need to make this one and this one to 0. So row 2 primes, row 2 based on row 1, row 3 primes, row 3 based on row 1. How I need to update? Let me enlarge this. Here is 4, here is 6 and here is 4. So the possibilities are 12 would be the LCM for them. 12 would be the LCM. So to make it 12 here, row 2 I need to multiply with the 2. To make it 12 here, I need to multiply with the 3. Since both are having the same sign, negative. Then here is 4, here is 2. So if I make it 4, means R3 I need to multiply with the 2. Since both are having the same sign, negative. So here first row is not altered, will be right as it is. 4 2 1 3. These two positions we made zeros. Now 2R2 minus 3R1. So 2R2 means 6. 6 minus 6 0. Oh great. 6 minus 6 0. Here 8 minus 3 5. Yeah, 14 minus 9 will be 5. Then row 2 R3 minus R1. Multiplying this with 2. So 2 minus 2 0. 0 minus 1 minus 1. 2 minus 3 minus 1. This is after first operation. Then further here to here I supposed to move, but unfortunately the elements below also 0. So thank God. Then I need to move from here to here. But no element below this one, so I'm stopping this one here. No element below this, I'm stopping here. So what I may get the ranks here, if I check rank of A is 3 because 3 non-zero rows, and number of unknowns were 1 2 3 4 4. Number of unknowns were 4. Since they are not equal, rank is less than the number of unknowns, then system will have infinitely many solutions. Infinitely many solutions. So how those can be computed? Let us check here. As usual, here number of unknowns are 4, rank is 3. So what's the difference here? The difference is 1. So I need to consider for that. Since the number of unknowns were 4 and rank of A is 3, that indicates we need to find the solution, we need to assume one arbitrary constant, then only I could able to find a solution, otherwise not. So in general, what my procedure is, we using the back propagation we use back substitution, so that's the reason I would like to prefer this one only. So let w equals to alpha I consider, then substituting that here. Let me just a minute. So I considered w equal to alpha. As per that, I need to write here ax equals to 0. So then x values are x, y, z, w equals to 0, which makes this here by back substitution method. I need to proceed this first. Minus z minus w equal to 0 implies z equals to minus w. Since w is considered as alpha, so implies z equal to minus alpha. Now from this, yeah, oh, still we made a mistake. In the beginning we told that here they are linearly dependent, means if I multiply, we thought that okay, it is easy, but here we multiplied this matrix with this row with 5 minus 5, I may get this. If I divide this row with minus 5, I may get this. So what the rank is, rank should be the 2. Let me correct this. Rank should be the 2. The number of unknowns to be assumed is, so here rank is 2, right? Rank is 2. Number of variables to be assumed is 2. So they are w equal to alpha, z equal to beta. So these are some questions where we usually confuse z equal to beta. So then what I can write here, since both are same, only the possibilities we may go with the first equation. The first equation is because okay, for your convenience, let me write one more step here. R3 primes, R3 based on row 2. So this row 3 multiplied with 5 and added to this. Then 4, 2, 1, 3, 0, 0, 5, 5, 0, 0, 0, 0. Then you may get a clear clarity. X, Y, Z, W equal to 0. So with that you may get perfect idea that rank is 2. Then rank is 2 means I supposed to assume that, assume that two variables are here. Last two if I assume here it is missing, since it is not available. Since it is not available, from this equation I supposed to extract y. If I assume z and w, I supposed to extract y. Since in this equation I'm not in the position to extract the y, so that's the reason this is one I'm opting. One among these I am opting. Let it be this. So let y equals to alpha, w equals to beta. So we should be alert in this. Then from this I may write here 5z plus 5w equal to 0, or dividing with 5, z plus w equal to 0, or z equals to minus w. Since I consider w equal beta, implies z equal to minus beta. So far we considered y equal to alpha, w equal to beta, and I computed now z equal to minus beta. Now from this I may write here 4x plus 2y plus z plus 3w equal to 0. Then plugging these values here, 4x plus 2y, y is here alpha, 2 alpha plus z, z is minus beta, and a w is beta, so 3 beta equal to 0. That implies 4x equals to minus 2 alpha plus 2 beta will be minus 2 beta, which implies x equals to 1 by 2 minus 1 by 2 times alpha plus beta. So if I list all those unknown matrix, minus 1 by 2 alpha plus beta is x value, and y value is, what is the y value? Y value is alpha, z value is minus beta, w value is beta. So this is, in this one what I am trying to do is here put if alpha equal to 0 and beta equals to 2, if I assume, then I may get one of the solution is this. What I may get here? 0 plus 2, or I may interested in minus 2. Suppose if I interested in minus 2, 0 minus 2 is minus 2, minus 2 by 2 will be 1, alpha is 0, beta is minus 2 means will be 2, this is minus 2. This is one of the solution is possible. The same is known as eigenvector also for this system. This is only the way. But here for what value we are computing eigenvector is not, we were not given clearly, but the procedure of eigenvector also the same way we may proceed. Hope you understood. Let me explain once again. In homogeneous it may have unique solution or infinitely many solutions. Suppose if I go with a system whose rank is 2, number of unknowns are 4, that means they are mismatching that. If the mismatching, which means system will have infinitely many solutions in the case of homogeneous. Then further, since the number of unknowns is 4 and rank is 2, means there is a gap of 2. So for that reason, to find the solution, I need to depend on the 2 arbitrary constants. So I need to assume the 2 arbitrary constant. Before choosing them, once again I am checking the given the coefficient matrix. In the coefficient matrix, here x and y are 0 remaining. So that means suppose if I assume w and z, which is of no use because still it is a hurdle for me. So that's the reason I assumed this is one among these two. So assumed is y equal to alpha or w equal beta. Then here people might ask the question that Sir, why we consider only y? Can we take x equal to alpha? Yes, that's up to you. You may take x is equal to alpha also. You may take x is equal to alpha also. Then in this equation, you may get the value of y. That's it. Nothing more than nothing more difficult in this. So plugging these values and fixing the x, y, z values, x, y, z, w values, and you may substitute any value and ensure that I mean to show, I mean to connect you that towards the eigenvector. In the eigenvector, if suppose if we consider beta equal to 0, alpha 0, beta 0, entire will be 0, that x is equal to 0. That means as we told for a homogeneous system, 0 0 0 0 is always a solution. Means trivial solution is means all the unknown values are zeros, then it is trivial, that is a solution. Apart from that, non-zero also we computed this one. That's now in eigenvectors. So to computing the eigenvectors, this is only the procedure we are following here. So how to compute the eigenvectors we'll discuss in next session. How to start the eigenvalues and how the eigenvalues and eigenvectors are originated is we explained here, and how to compute them will be discussed in next session.